Welcome to the Consulting Specifying Engineer webcast, How to Design Electrical Distribution Systems in Data Centers, sponsored by Starline, a brand of Legrand. I'm your moderator, Amara Rozgis, and I'm happy to join you today on behalf of Consulting Specifying Engineer. Here are some tips to get the most from today's webcast. If you are experiencing any issues with your audio or the slides, refresh your browser or click the Refresh Media button directly under the presenter's photo. You can control the volume of this webcast by controlling the volume on your own device or by adjusting the volume on the webcast platform. If you're having technical problems with the audio or with the slide presentation, click on the question mark at the top right corner of your screen to access some system checks. If you do need a technician, type a message in the Ask a Question, and the tech team will get to you as quickly as possible in that box. Individual user experience questions will be answered in that Answered Questions box. Type questions for the speakers in the Ask a Question box on the left side of your screen. Today's webcast is being recorded, and you'll receive an email within about a week with a link to the on-demand version of this webcast. To download a certificate of completion and a PDF copy of this presentation, use the Event Resources tab on the left side of your screen. Those documents will also be available with the on-demand version of this webcast. Now we will hear from the sponsor of today's webcast, Starline, a brand of Legrand. At the conclusion of the video, you may experience a few seconds of silence to make up for different internet speeds. Please stay tuned after the video for today's presentation.
For data centers worldwide, Starline track busway systems support the ever-increasing power demands of IT infrastructure. Our remote plug actuation system provides hands-free plug-in unit engagement, enhancing flexibility and safety for those working in critical spaces. Trusted for over 3 decades, Starline continues to pave the way for electrical power distribution systems for mission-critical environments.
All right, well, I'm happy to introduce today's presenters, Chris Ocean, Nick Funyak, and Daryl Kachansky. Chris is currently a product manager of Starline, a company of Legrand North America and Central America. He is responsible for a global portfolio of data center products at Starline, including busway and metering products. He has more than 15 years of experience in product and application engineering roles. Chris has a bachelor's degree in electrical engineering from the San Francisco State University and an MBA from Golden State University. Nick is the Field Service Program Manager at Starline. Nick is responsible for the sales and operations of the Field Services Group globally and has developed and deployed international service strategies, which help clients achieve their current and future goals of maximum uptime. His nearly 10 years of experience with Starline in various engineering and leadership roles, and leads his team through successful installation and testing of Starline equipment. Nick has a bachelor's degree in mechanical engineering from Point Park University and an MBA from Robert Morris University. Daryl is currently the Director of Technical Services at Starline, a company of Legrand North America and Central America. He oversees the global application engineering and service teams at Starline and has more than 16 years of experience in product and application engineering, as well as a role in field services. All right, so let's get started. Daryl, I'm going to kick this off with a question. What are the typical power distribution methods in the data center white space? Can you go into a little detail here, please?
Yeah, great question, Amara. Thank you for having us. As we said, there are typically 2 options when it comes to power distribution systems for your data center white space. You can either run your power under a raised floor or suspend it from the ceiling overhead. Typically, a UPS will feed that AC power distribution into the white space, via a PDU, a power distribution unit, or an RPP, a remote power panel. From there, it can be fed into a bus bar or individual branch circuit power whips that will power the cabinet power strip. So, let's dig into each one of those. Let's first look at the option of RPPs and power whips. A power whip is just essentially a branch circuit, a power distribution cable used to carry power from the remote power panel directly to that IT rack. Power whips are typically run underneath a raised floor, and in some instances overhead as well. On-site electricians, however, are required to terminate the whips to the RPP. With that underfloor power distribution, that can potentially create a mass of wires under that raised floor that may restrict airflow and in turn create hot spots and cause you to increase the cooling demand in the data center itself. If a raised floor space is not available, then the installation of those power whips and cost can be higher because it's forced to go overhead, and dedicated ladder or cable tray will be required. And this can be expensive and create challenges in certain spaces. And also, let's take a look at the option of overhead busway. Overhead busways such as the Starline provides a convenient, energy-efficient option. They're typically run in pairs, an A feed and a B feed from different sources for redundancy purposes. The busways are run above the IT equipment cabinets down the length of the busway, down the length of the IT row. The receptacles themselves or cords are housed in plug-in boxes that attach directly to the busway at intervals where the end user needs those. And, continuing to look at the overhead busway solutions, overhead busways do not require any cable or ladder tray or raised floor to distribute power. Since the busway is has readily accessible receptacle and cord installations, the installation of those devices and moves are simple. Also, because the tap boxes are factory assembled, you eliminate the time and cost associated with on-site wiring to build those circuits and terminate those circuits. We can also offer power monitoring in our end feeds to monitor the entire busway run, or the individual plug-in units to monitor at the branch circuit level. So if we look at this slide here, for those who aren't familiar with track busway, very basic. Typically in data centers, we see an end feed, which is the power feed indicated on that slide there, and simply straight runs of bus from there. But some instances do require T's and elbows, which we have as well. So I just wanted to show this to present to the audience who haven't used busway or aren't familiar with that. But, looking at the options of underfloor versus overhead, both power methods have been used in the white space for several years. But a majority of projects that we're seeing deployed now are going overhead for the reasons previously mentioned. Overhead busway, obviously, for the ease of installation, the usage benefits of busway, and the reliability.
Okay, so this then leads me to my next question. Chris, I think you're probably best suited to answer this one. What can be done in the design stage to help future-proof busway systems in data centers? And then, in turn, what kind of artificial intelligence technology trends are affecting those designs?
Yeah, so I think to future-proof, your busway design, you really have to look at the life cycle of the data center, right? We're seeing the life cycle of the data center roughly in that 10 to 15 year kind of range. And so when you're planning to design your data center, plan for that amount of time. And also just think about, 8 years down the line, what kind of power requirements are going to be had. And the reason why AI technology is important is because we've seen just this large push and increase in power density over the years that you just need to be mindful when you're planning out your data center that you're, accounting for this increase in power. To paint a picture a little bit of what we've been seeing over the years, say 10 years ago, we were supplying 7 kilowatts per circuit for a rack. Fast forward a couple years, it was in that 10 to 20 kilowatt range. And then today, some of our high runners are around 22 kilowatts per circuit and even up to 43 kilowatts today. But we're also getting requests for much larger than that. We've gotten some rare requests of doing over 100 kilowatts as well. And so what you're seeing on the screen is kind of our product offering, or just a snapshot of our product offering for AI. On the left, you're seeing our 1200 amp busway open channel that can supply up to 996 kilowatts per run. And on the right, you'll see kind of our higher density plugs, which is a dual 60 amp that will give you roughly 40 kilowatts per circuit. And then the single 100 amp will give you roughly 66 kilowatts. And even to bring more context, again, 8 years ago, 10 years ago, we were distributing 250 and 400 amp busway runs pretty regularly to hyperscalers, data centers. Today, we're more commonly seeing requests between that 800 amp and 1200 amp range. So you can see that the amount of power required by AI is nearly doubled at this point. So when you're thinking about designing, your data center, just keep that in mind to allow for, to future-proof your design at that point. And a couple comments too, we're seeing that this increase in density is changing some of the environment around it as well. So we're seeing liquid cooling be a little bit more prevalent near the busway system as well. And what that is doing with our busway system is that we're having to modify our tap boxes a little bit. Because the liquid cooling is closer to the busway, clients are now asking us to monitor the tap boxes in terms of auxiliary to know the state of the breaker. So you can get that real-time info if something were to happen downstream. But not only that, they want control over the tap box itself and allow for a remote trip. So what we're doing is we're adding these shunt circuits as well to the breakers to allow for a remote circuit to snap off the tap box power. So these little things that we're seeing are all being, again, driven by AI. And as you're planning out your data center, your next data center, make sure you capture all of these in your drawings, your specs, and your CDE. And there's always a Q&A session that you can have with the vendor to ask questions like this as well. So that's just my advice right now, as we're seeing kind of this AI push and especially advanced technology for busway design.
Okay, good point. So let me ask you the next question, bring this in here. What tools are available to help customers better understand the environmental impacts of their initiatives or of their products?
Yeah, so we've had this ongoing project, and what you're seeing on the screen is a product environmental profile. We know it's important for customers to meet their CSR goals, to really know the impact of what they're actually putting into the data center. So we've made this environmental profile for each one of our systems, and even further, each one of the major components within the system, to give you information that you can feed into your CSR. For instance, we have bill of materials, we have energy consumed during manufacturing, energy dissipation, while in use, and also kind of a material composition of each of those components as well. So all of this information is really intended to give a customer or a client information to pull that into their kind of larger infrastructure environmental footprint, and to see what kind of impact it has from a system as a whole. So this is available for each of our kind of major T3, T5 products. And you can just go to the Starline webpage, or even get with myself or one of your local contacts to get this type of information.
All right, let's switch gears here a little bit. Nick, this is probably something for you. What are the 5 levels of commissioning, and how does that work? What's a brief description of each?
So that's a great question, Amara. So, commissioning is one of those things that, I do a lot of these different types of conversations with spec engineers. One of the biggest things that I ask everybody is, who knows the 5 levels of commissioning? I get a lot of hands that go up, but when I ask the question, who feels comfortable enough to speak about these 5 levels of commissioning, a lot of hands go down, right? A lot of the spec engineers we're focused on, and myself included, are focused on materials, but we forget about the side of testing those materials. So, commissioning is just a fancy term for basically testing, and there are 5 levels of it, right? So we have a factory witness testing, which is kind of our level 1 in our design review, right? So, and oftentimes what will happen is for like UPSs, PDUs, it's very common for the spec engineer to go to site, or the customer to go to site, to the manufacturer's location, and watch that system get tested. Overhead power distribution systems like busway, it's typically not very common, but we do have some folks that specify that. Now, a lot of times in those situations, we have a lot of factory testing that happens, on that busway. So prior to it leaving the factory, it is fully tested. And a lot of times that's not required. And then you get into your level 2, which is basically a site acceptance testing, which means that once the material has arrived at site, it's good to go through all that, make sure that it's confirmed, everything is there. And then this is a good time to set together all of your test specifications moving forward into level 3, 4, and 5. Okay, so it's basically a check sheet that you're going to develop with the help of some of the manufacturers as well, that gets you prepared for your next couple of sets of testing. So when we get into level 3, which is startup and pre-functional testing, on electrical equipment, this is typically when the equipment is de-energized. So it has not been powered up, and that's a key factor, right? Because you do not want to power up the busway or any type of equipment, UPSs, PDUs, any type of switchgear, without actually running some tests on that, because a lot can happen between the factory and being installed. So a lot of the level 3 gets done prior to energization. And then once that happens, right, you're doing visual inspections, some electrical non-intrusive inspections at level 3, you kind of jump into level 4. And I always kind of describe level 4 as a more selfish type of inspection, because you're going from vendor to vendor, and they are basically selfishly looking at their own equipment. They're looking at functional performance testing of that equipment. With overhead busway in particular, we're going to pull a 2-hour load across that bus. If it says it's going to be 1200 amp busway, you're going to pull 1200 amps across that. It's very, very important to specify that. And then you're going to do some thermal scanning across each one of those joints to make sure that, hey, this busway is said to be tested at 1200 amps. It's going to work at 1200 amps. You're not going to have any issues, right? This is the time where you find any installation problems. And then you jump into level 5, where it's integrated system testing, right? So it's almost like a stress test on your body. I like to explain it as that, you're running on the treadmill, you're doing the same thing with a data center or an industrial facility, where you're testing everything and you're cutting power from the incoming power coming into the building to see, well, can I hold my load downstream? Will my generators kick on? Will my transfer switches work? And we track that all back to the busway, right? Is that going to hold that load? And, you want to get your manufacturers involved in those tests, because, it's very important. And we see a lot of spec engineers kind of forget about that. And, as an engineer myself, and in the past, I've done a lot of specifications for electrical power distribution. One of the biggest things I forgot about was commissioning, right? But I looked at it and said, okay, talking to some other customers and other folks in the industry, we ran across them and said, what's your biggest struggles, right? And their biggest struggle is, I run 5 different locations, but when I install equipment, I get 5 totally different installs, and that has to stop, right? So they're saying, how do we prevent that from happening? And you prevent that from writing good commissioning specs, getting your manufacturers involved, having those guys train some of the third-party contractors, because as spec engineers, we don't always get to choose those contractors, right? We get to choose the material and how that gets installed, but we don't get to choose those partners, right? So in order to kind of safeguard yourself and give you that safety net, I like to personally put in, look further past the material, look further into the commissioning side of things, and ask your other vendors that you're working with about this, right? Get those guys involved. Ask them about their specifications. Ask them for their specs, right? So that you're not reinventing that type of wheel there. One other thing that we see oftentimes too is that, have them do the testing from the manufacturing standpoint, right? Because that gives them some skin in the game. so that oftentimes they'll offer extended warranties when they do so, and they're not going to cover something that they don't feel is perfect and the install is correct, right? You get a nice unbiased opinion on it, whereas they weren't the ones that installed it. They're sending the correct people there to do it. In this particular instance, you would want somebody who has load banking experience, somebody that has a FLIR certification, right, for thermal scanning. I can't tell you how many times we go into these things and we look at different testing results, and you can tell immediately that the guy that tested it, he has no experience in thermal scanning, right? You want to make sure that you're hiring the qualified people to do so.
Okay, so Nick, you talked about commissioning, you talked about testing. What about maintenance? What is NFPA 70B? Why is it important? I mean, what needs to be considered here?
Sure. Yeah, so the other part of, after commissioning, after the systems in your building has been handed over to your customer, one other thing you need to consider is maintenance of it all, right? Each system has its own level of type of maintenance, right? We're talking about overhead busway here. In this particular instance, right, it's a very static system. But what I find oftentimes is that I find a lot of spec engineers kind of telling the end user, saying, hey, you know what, you don't have to maintain it. It's maintenance free. And, from a lot of people, a lot of manufacturer standpoint, it is. But there is a standard out there called NFPA 70B. It used to be a recommendation for electrical maintenance. And I think back in January of 2023, they changed this over to the standard, meaning that it is required. And folks like OSHA and whatnot, they follow these types of standards that are set in place. So I've always been very keen on working with spec engineers, working with end users, and explaining to those guys it's very maintenance free, but it would be naive to kind of neglect it, right? This is a mission critical type of piece of equipment. You want to add that, right? So help our customers out, help your end user out by guiding them into that, right? Talk about the importance of it. Don't forget about even on the material side of specifying IR windows for thermal scanning through. My team in particular has been going around a lot of times now and getting a lot of requests on how do we comply with NFPA 70B standards now, right? And a lot of ways to do that is, okay, let's add some IR windows to your feed so that we can check on your lugs. Let's go through and do a preventative maintenance plan, and we'll verify all that. Let's do it on a 1 year or 2 year basis. Let's be fair with it and make sure that we're not overdoing it, but not underdoing it as well too. And make sure that we keep that customer in that data center or industrial facility up and running.
All right, Chris, let me bounce back to you. And this is kind of a multi-part question. Maybe you'll go through this here. Once a data center is live, so how do you add a circuit in the field? Can you add circuits when things are energized? And then are there safety considerations? I know we just talked a little bit about the maintenance and the commissioning, but what safety considerations are involved, Chris?
Yeah, so there are several layers to this, right? Since Starline has been distributing busway to data centers and the inception of the design, we are designed for live insertion by ETL and other listing bodies, where a big criteria that UL and ETL has us designed to is making sure a fault path is established throughout the install or removal of a circuit. So the way we do that is we establish ground before any of the energized conductors make contact on adding a circuit. And then on removal, ground is the last contact out. So you will always have a fault path established when you're installing or adding a circuit to Starline busway, and that's a big reason why we're designed for live insertion. So on top of that, you still have to follow your local codes like NFPA 70 and ensure you're complying to those. But Starline is designed for live insertion. And this kind of goes back, so this slide goes back to what I was talking about earlier in increasing power demand, right? We're seeing AI really push power densities, and this is data center energy demand over from 2014 and projected to 2029. But what you'll see here is over the past 10 years, really power has doubled over the last 10 years, and it's only increasing from there. So this is really to paint a picture that, again, there's increasing powers here. And although we're designed and we're definitely set up to install circuits live, some of our customers prefer to shut down in that scenario, especially if it's kind of a higher power situation. So with that said, just a slide here showing kind of the boundaries that NFPA 70E defines, right? In the center, you have your arc source. And just outside of that, you have your restricted and your limited approach boundaries, and those are voltage dictated. But just outside of that, you have your arc flash boundary, which varies based on what kind of electrical characteristics that your data center has. But you'll notice that personnel is just outside of that, because that is one of the safest places you can be with respect to, an electrical arc. And so the reason why I'm showing you this is there's an innovation that we're doing within Starline where we're allowing a user to be outside of that arc flash zone, but still engage our plugin. And we're doing that by using what's called a remote plug-in actuator. And really, it's intended to enhance operator safety. And you saw a little snippet of it here in the introduction. But what this kind of tool allows us to do is to plug the busway plugin into the open channel without ever engaging the electrical conductors there. So it'll mechanically strap to the busway first with the tool, and then you can go up to 30 feet away and engage it either by Bluetooth or fiber optic cable, which are both electrically isolated from the unit, and you can be just outside of that arc flash zone and engage your electrical conductors from there. This greatly enhances the safety of the operator because they don't have to be, again, in close vicinity to engaging those electrical conductors. On top of that, we have torque sensors and safety features built into where, say, for instance, if it's malpositioned for whatever reason, the tool senses that and it'll stop. So there's built-in features even within that allows the user to be, again, safe from an arc and then safe from errors in installing as well. So we're doing this, again, to enhance this operator safety. This is coming out towards more or less the end of the year. I'm open to feedback and questions on this. Feel free to fill them out in the Q&A.
Yeah, good point. If you have a question, feel free to type your question into the Ask a Question box, and Chris or someone will take on that question. So Nick, let's talk about retrofits here. What happens when a data center is near end of life? What options are available?
Sure. Yeah, so you don't have just one option of, lots of times when a data center ends near a life, that equipment is so well dated that it cannot be reused, right, or salvaged. With overhead busway, right, that's typically not the case, right? So we have quite a few different folks out there that say, okay, my busway is my data center is coming to end of life, or I just want to, relocate my busway. My data center? What do we do with this, right? Is there an option for it? Can it be scrapped? Can it be repurposed? And the short answer is with overhead power distribution, yes. You can reuse things like busway. It's typically made out of aluminum or copper, right? So those are two very, very recyclable types of material. And it could either be obviously recycled to a scrapyard, or if you'd like to move it around, you can do that. Now, in our particular case, right, we do allow some customers to move their busway from one location to the next. It does a couple things, right? It allows those guys to save some money on the move, right, and not have to purchase new. But it also allows those guys to comply with some of their new CSR metrics, right, where they are trying to reduce their carbon footprint. And by doing so, right, that means they're not buying a brand new system and scrapping the rest. So in those situations, what my team will do is we will set up some specifications with the customers, and we will go to site and basically recommission that busway after it's been installed again. And then we, us in particular, we offer extended warranties with that, almost like it's a brand new system. Okay, so it's a win-win on that end of it, right? So we help reduce that carbon footprint from a company standpoint, and our customers are happy with that as well too.
Okay, well, awesome. Lots of information there. Now, Daryl, Nick, and Chris will answer questions from the audience. Type your question for the presenters in the Ask a Question box on your screen, and we will get to as many as time allows. Please type the presenter's name before the question so that I know who to direct it to. Questions that we don't get to today will be posted online at www.csemag.com, csemag.com. And remember to download a certificate of completion or a copy of this presentation. Use the Event Resources tab on the left side of your screen. All right, gentlemen, on to the Q&A. And Daryl, I have selected a question for you first. Kind of a general question. What is the max amp tap box available?
Yeah, great question. So our typical plugins are rated up to 120 amps, and that's our standard footprint. So smaller style enclosures that can fit directly above the rack. We, however, can provide plugins up to 600 amps. For circuit breaker only units, Nick's team uses those quite a bit at 400 amps for load banking and commissioning purposes. So we can essentially go all the way up to a 600 amp unit with our plug-in units.
All right, very good. Thank you. Chris, this next question is for you. Can you talk a little bit about the conditions where busway ampacity derating should be considered?
Yeah, that's a good question. We see the majority of installs in cold aisle containment, but if you're actually installing in hot aisle, you definitely should consider looking at a derate on the busway. We have multipliers present in our spec sheets. We generally operate between 0 and 40 C as our operating range. So if you're in that hot aisle containment, you'll want to start to look at a derate above 40 C for busway.
Very good, thank you. Let's see here. Nick, a question for you. What is the most common reason for failure that you've seen with this product? And then kind of a follow-up, is it installation, environmental conditions? Can you talk about that?
Sure. Yeah, that's a great question, right? So obviously the overhead power distribution systems like busway are a very static type system. I always like to explain it as it goes together like Legos, kind of snaps in place. You have some joint kits. But the biggest part of the failure is typically due to the install. That's why it's very important to specify things like the manufacturer to come out and perform the startups. Even with Starline, our instructions will say, hey, every 10 feet, you want to have a support. And I've personally been on sites where I walk in there and they're on 30-foot centers. And they have, 20-foot sections of busway hanging in the air with a large bow in them, right? And then surprisingly, they're asking why they're not working, right? So that's typically in industrial facilities. We see that kind of things like automotive factories, just because of due to the spacing. But it's very important you have to choose the right partners to get that right. No different than anything else, right? Even if you were going pipe and wire with it, you want to have a good partner in there who can install that correctly. But that's definitely where I see the most failures at. And then on a metering side of things, we very oftentimes see contractors that will put CTs on their incoming wires coming into their power feed backwards, and then they'll wonder why their metering is reading incorrectly and reading negative kW values. And that's typically a pretty good indicator that it's just installed wrong. And there's ways around that we could help, mitigate the risks for that and really help, reduce the exposure to the customer end on that thing to make it right.
Sure. Okay. Lots of questions here. If you do have a question, type it into the Ask a Question box. Daryl, this next one is for you. How does the busway support system change as you increase the size of the busway?
Yeah, great question. Each one of our busway systems are required to be mounted on 10-foot centers, as Nick just described with the installation. The hanger method does change. It becomes larger depending upon the ampacity and the weight of the system. We have larger hangers for our 1200 amp systems that are typically hung from 1/2-inch threaded rod. We can direct connect to hot aisle containment systems. We can direct connect to Unistrut as well. And we also see the busway in some instances hung directly from a structural grid in the data center also. So we have various options, various mounting methods. They're all pretty much the same. The hardware may change just to support the larger and heavier weight of the busway systems.
All right. Chris, another question for you, and this is, again, multi-part question. Does the remote actuator stay with the specific bus plug after the plug has been remote actuated? Can you pull it off? Is it standard? Like, go into a little bit more detail.
Yeah. So it does not stay with a specific plug. We have a mating receptacle with our plugins. If that add that feature, it's called a rotating paddle, and that the bottom of that rotating paddle actually mates with the tool. So as you're adding or removing these circuits, you remove the tool specifically from the plugin and install it on the next one you intend to install as well. So we don't expect, obviously, 30, 40 of these at a data center. It's probably going to be 1 or 2 per room, and it's typically intended for live data centers, right? You wouldn't use this on a day one install because you have the ability to turn on and off the busway at that point. It's really intended for operation.
All right, thank you. Nick, the next question's for you. This is talking about factory testing. This person's never heard about factory testing being done on site. Is that a thing?
So factory testing on site at a customer and end user site would be no. That's typically going to be pre-functional testing and functional performance testing. Factory testing is typically done at the manufacturing's level. That would be on the manufacturing site, not the end user's site. So typically that's going to be when an engineer will fly into, let's take, for instance, Starline, and they will watch their busway be tested at Starline's facility, much like a UPS. So on site, no. If I misspoke on that, I may have meant just our own manufacturing site, but definitely not on end user site. You are correct there, David, as well too. Factory acceptance tests would not be done on the customer or end user site.
Great, got it. Thank you. Daryl, next question for you. What would be the prime factors in choosing between sandwich style busways and track style busways?
Yeah, great question. If we're talking about data center power distribution, the difference is typically the ampacity limitation on the open channel or Starline style busway systems. As I previously mentioned, our system does go up to 1200 amps, and all of those systems are continuous access, meaning that you can place one of our plug-in units anywhere along that open channel, along the entire length of the bus. Anything exceeding 1200 amps currently we're seeing move toward the typical sandwich style bus duct system. So right now we're really just seeing that sandwich style deployed where higher ampacities are required.
All right, thanks. Nick, next one is directed to you. Can the remote actuator be provided without Bluetooth or wireless capability for secure facilities? So I guess we're talking about cybersecurity here. Talk to me about that.
Yeah, absolutely. And I'll chime in there, have Chris chime in as well too, if you feel the need to, Chris. But the answer is yes. You could use the fiber optic cable that comes with it. It comes in 2 different options. So we understand that a lot of data centers have a high security risk with any Wi-Fi or Bluetooth. So we did create them in both ways. Some industrial facilities, they don't mind having the Bluetooth and it's preferred. But there's larger data centers who are looking at security risks. They would look at the fiber optic type cable, which Chris had mentioned is about, you can get about 30 feet out with that. I think it's a 10-meter cable that's on there.
Yeah, and I'll add to that as well, Nick. It's an either or, right? I listed it as 2 bullet points, but you'll either get the wireless or you'll get the fiber optic, not both. So if you are going into a secure facility, you will definitely want to use something that's hardwired, like the fiber optic cable, and not get the wireless version because there are concerns over security there.
Okay, thank you. Daryl, I'm going to start with you, but maybe all of you can answer this question. What other applications are there for this bus bar other than data centers? That's what you focused on here, but what other facilities or buildings can this be used in?
Yeah, great question. I mean, the busway systems can really be deployed anywhere. There's a need for continuous power, a need to add circuits quickly, change those circuits out, even lighting applications. We've deployed bus. Where we primarily see it is the data center space. However, we have a great market share in the retail space, in manufacturing, data center space. We obviously use the product on our factory floor, and our operations personnel loves it because anytime they have to change work cells or locations of tooling, equipment, things like that, they can very easily go in and make that change throughout our facility. So, we're seeing it really anywhere power is needed. This product can be deployed, but our primary markets are automotive, retail, data center, those types of applications.
Okay, so quite the variety. Thank you. Chris, here's another one for you. What is the withstand current rating of the busway?
Yeah, it varies by ampacity that you're selecting on the busway. Our 1200 amp, I believe, is rated up to 65K or 75Ka. So, and then we have ways of doing fused end feeds too. So if you have available fault currents that are higher than what the busway is rated for, we can consider putting in fuses as well to help mitigate some of that. But it does vary on ampacity. So.
Right. The general answer, it depends. All right. Nick, another question for you here. Do you provide sample IT loads for factory acceptance testing that are realistic to full load?
Yeah, so when we're talking factory acceptance, that would mean that we are doing this out of Starline's factory. And we've developed a little system, we call it the APT machine. So it stands for Automated Plug Testing Machine. And this goes along with all of our busway as well, too. We will go through a series of tests. And typically what that means is for a plug-in unit, we will plug that up into a piece of sample busway. And we will hit this machine. And it runs through a series of about, I believe it's about 8 or 9 different pages of just tests, right? And it'll verify that it has the correct receptacle on there, the correct breaker on there. It'll check it with a serial number on the back. And it'll go through a series of tests. If it has a meter, it will provide some load to that meter to verify that the meter is calibrated correctly and functioning. The CTs are facing the correct direction. So we do supply that load. If it has a receptacle on that plug-in unit, we push a male receptacle into that's connected to this system. The same goes for our bus duct or our busway and our end feeds. We test all of those with a load as well too. So that's factory acceptance testing. And then when we get out in the field, we will also pull a full load through load banking on that busway.
All right, got it. So speaking of busways, Daryl, this question's for you. Are you seeing customers and clients using more overhead power distribution or underfloor distribution? What does that look like?
Yeah, it's still a mix of both from what we're seeing. Obviously, coming from Starline, we see most people using the overhead power distribution. It is becoming more prevalent with the lack of raised flooring in the data center space now, and more demand for power directly over the equipment. I think the trend is heading toward the overhead power distribution more than it was underfloor in the past.
Okay. Chris, this next question's for you. We kind of talked about the end of the life of the system. Is there anything in the pipeline for the removal of the plug on the units, or I don't know. Can you talk a little bit about that?
Can you repeat the question? I don't think I quite understand it, Amara.
Is there anything in the pipeline for remote removal of the plug on the units?
Oh, I see. I got you. So it is the same tool from adding a circuit to removing it. So if we're talking about the remote plug-in actuator, it goes both ways. You can rotate it in and engage your electrical conductors, but if you want to remove a circuit from the plug-in, you can use that same tool to disengage the conductors as well. So yes, it is in the pipeline, and it is the same tool as you would add a circuit.
Great, thank you. Nick, another question for you. This is about electrical rooms and design. On the main disconnect of the bus duct, based on NEC 240.24, the disconnecting means workspace must extend from the floor to 6.5 feet. So 6 feet, 6 inches. How can this be maintained with the bus duct system?
So if I'm understanding that question correctly, and I have to look at the NEC code as well too, my understanding is that the question is based around how do we actuate those breakers from the floor, right? NEC requires that the breakers have to be what they consider floor operable. And in this situation, right, from the busway, it can be hung above that level. And we have a means of doing that because we do not encapsulate that breaker into the plug-in unit. It does stick out the front of it. And we are able to provide the end user or somebody working in that area with a breaker actuator stick that can push that breaker up and down and reset that from the floor. Obviously, fuses are the same way. We do fuses with, CCP fuses with an Eaton fuse disconnect that does have a handle switch on there as well too. Same deal. You could flip that on and off from the floor. Obviously, if you want to replace the fuse, got to get up on a ladder to do that. But that is all okay with the NEC code. So if I did not answer that the way you wanted it, please resubmit it, and then we'll make sure we get you an answer. But that was my understanding of that question there.
Right. Yeah. If you do have a question or a follow-up question, you can type your question in the Ask a Question box on your screen. We do have a few more minutes for questions here. Daryl, this next question is for you. Is it possible to add tees and fittings to the installed busway without shutting it down?
Great question. No, unfortunately, it's not. If you have an installed system that you do need to add tees or elbows or additional sections to that particular run of bus, it will need to be shut down and isolated appropriately. The entire run is energized, and we're making the connections at the joint location. So we're adding electrical connections from one section to the new section that you want to install. So it will require a shutdown.
Sure. All right, more questions here. Chris, next one is for you. Does every tap require the remote actuator, or is it removable after use so that it can be used on the next installation?
Yeah, we really have two types of tap off. One is with the rotating paddle, and one is with our original design, which is not a rotating paddle. With the latter, our original design, you would essentially rotate the entire plug to engage, and you have to be present, obviously, at the open channel to do that. The second type is the rotating paddle with the mating receptacle for the RPI, and you have to order them out of the factory in an either or situation. So if you're planning to use the remote plug-in actuator, you have to let your Starline team know that up front so that we can get you the appropriate tap box for that particular tool.
Great, thank you. Well, Nick, I have another question for you. Does Starline provide a busway connection point for full load field testing?
So we do. There are a couple of different options out there for that, right? Obviously, NFeed is one of them. But that's a thing of the past, really. What we've developed is we have a small little box. We call it a load bank box. They could actually be rented directly from Starline or purchased. And our rented units are smaller. So they're only a 12 by 12 type of unit in inches wise. And you'll basically put that up into the bus duct, and you'll spin that in no different than you would any other plug. It has a set of cam locks on there that you'll be able to connect into and connect to the load bank. In that particular case, right, for 1200 amps, if you're aware of the cam locks are restricted at 400 amps. So although our paddle head will go up to 600 amps, we're restricted to test that out at 400 amps. So you would have 3 of these smaller units tied in at the end of the bus. So you'll take those, install those, and then you hook your cable and your load bank up directly to those.
Great, thank you, Nick. Daryl, another question for you. This is referring back to the graphic that you showed on one slide. What are the boxes at the end of the busway?
Yeah, great question. Those boxes are what we refer to as our end feed boxes. So that's essentially where the conduit and the connecting cable is feeding that particular run of busway. It can be fed either directly from switchgear, a circuit breaker panel, or in the case of the data center, the upstream PDU breaker will feed directly into that box. So inside of that box, we will have either mechanical lugs or compression lug capable blades for that electrical contractor to land his cabling to. We have various options from a Starline perspective on lug packages, accessories in the end feed, especially, when it comes to what Nick mentioned, IR scanning and commissioning. We can place IR windows directly on that feed unit for thermal scanning during that initial load bank testing, or during your annual testing when Nick and his team would come out and do that scanning for you as well. So that's essentially what brings that power to the busway, and there are numerous options available from us to do that.
And to add to that too, we can also monitor at that point too. We can add basically a monitoring solution to allow you to get visibility on how much power is running through the busway at that point. And we also have monitors that are available in the tap box location as well, if you're interested in some sort of load profile of a device as well. So.
All right, Chris, you're already talking, so let me ask you another question here. Is there specific requirement for area with a higher earthquake possibility? So what are the seismic requirements here?
Yeah, we have a standard offering and we have seismic offering as well. We've shake tabled the busway to meet IEEE 693, and we also have OSHPOD available as well. So if you're in an area that has a seismic zone, we do have product available to help satisfy those type of requirements as well. So yes, the answer to the question is yes, Samara. we have that available.
Yes, got it. All right, Nick, here is a question for you. Are busways field configured, and can you talk more about the reuse of them?
Sure. So busways, obviously they are UL listed, and there are a set of creepage and clearances that we need to abide by. So our recommendation on that is you cannot configure the busway in particular, right? So if you're looking to say, hey, I ordered a 30-foot run and some changes have been made, and I need to drop this down to a 25-foot run, you cannot cut that in the field, right? It may seem very easy. We have had guys do that. And I have been on sites where we have tried testing busways out, and we find that they failed, right? When we track that down, we find out that the busway was cut smack dab in the middle with an end cap put on the end of it, right? If we were to energize that, that would see some serious issues, right? So we want to make sure that we abide by all those creepage and clearance rules, and that we aren't cutting that in the field. Now, granted, as an engineer, I don't want to have just one way in and no way out, right? So there is a way out, right? So let's say you guys did specify something and you're on site and your project manager says, oh man, I screwed up. This should be 5 foot less, right? There is a way out. You can call Starline up, any other manufacturer. You should be able to cut that in the field with a technician, right? We have a series of saws that travel around in a plastic buckhorn for this exact situation, where we could help get people out of a bind if, in fact, you have some busway on site that maybe a little bit longer than expected there. Again, going back to the reuse of it, right? It is configurable from the standpoint of you could change your tap boxes in and out. So once you put a tap box in, you're not stuck with that tap box. If you wanted to change it or move it 6 feet down, it's very easy to do. You pull it out, drop it down on the bus, move it over, put it back in. So really simple on that side of things. For the reuse side of it, it can be reused. We are seeing a lot of customers. We just recently moved one out of Chicago down to a site in Arizona, where they had said, hey, we're just moving our data center down there. It was a co-location data center. Can we do that? Reuse the busway? It was about 6 or 7 years old. We were able to do that, re-warranty that busway, and give that co-location provider that sense of, a warm feeling inside saying, hey, we came out, we looked at this busway. It's still good. It tested out just fine. We're going to be able to certify this again and, actually warranty that for their end user as well.
Got it. All right. So I have time for one more question. Nick, this one actually goes to you, though any of you are welcome to chime in. Why is the lifespan for a data center only 10 to 15 years?
Yeah, that's a good question. I've seen a couple of questions popped up in there around that 10 to 15 year lifespan. So it's not really a requirement by the data center. It really comes down to the systems in there just become so inefficient because we've come up as engineers, we've just come up with better, more efficient types of batteries and UPSs and PDUs and switchgear upstream, where 10 to 15 years is typically that lifespan of saying, hey, I can now build a data center and have it work more efficient, have more density than my space that I'm taking up right now, right? With the same floor plan that I have, I could have more power in that floor plan with better equipment. So typically it's just the lifespan of the equipment is just becoming dated. It goes no different with our busway. Our busway after 10 or 15 years, you could reuse it. But if it was 250 amp busway, you now might be looking at, 1200 amp busway or 2000 amp busway, where you're saying, hey, my equipment is better and I'm going to need more power upstream.
Yeah, we often see requests to add more power to a particular run. And in some cases, like in a retrofit situation, we could break a run in half and then feed another end feed on the opposite side, essentially doubling the power of that row. So there's opportunity there in that where you can actually increase the power at that point. And we've seen requests like that over the years, especially if it's an older data center.
Yeah.
Wow. Well, that is a lot of information. Thank you to our speakers, Daryl, Nick, and Chris, for sharing their time and expertise. And of course, thank you for all of those fantastic questions. I would also like to extend a special thank you to the sponsor, Starline, a brand of Legrand, for sponsoring today's event. And now that we are just about done, we want to hear how we did. An exit survey will pop up on your screen as soon as this webcast ends. Please take a moment to complete this information to help us improve future events. Finally, on behalf of Consulting Specifying Engineer, I'd like to thank you for attending. This now concludes the webcast. Thank you and goodbye.